AGHAMAZING, my dear students! Welcome back to our science video lesson. I am your science teacher, Teacher Larry, and welcome to AGHAMAZING way of learning science. In our last video, we were able to define and describe motion using the concept of speed and velocity. In this video lesson, we are going to describe motion using the concept of acceleration. Are you ready to learn? Let us begin. Objects do not always move at constant velocity. Objects do change their speed, directions, or both. When objects change their speed or velocity, they are said to be accelerating. Acceleration is usually associated with a change in speed. When something is speed up, we say it accelerates. But acceleration involves more than a change in speed. Acceleration refers to the rate of change in speed or velocity at a given time of an object. It gives an idea on how quick an object speeds up or slows down. But how can we say that an object is accelerating? An object is accelerating if it does any of the following. Number 1, the speed of the object is changing. Number 2, the direction of the object is changing. And number 3, the speed and direction of the object is changing. An increase in speed or velocity is called a positive acceleration. On the other hand, a decrease in speed or velocity is called deceleration. This means that acceleration does not always mean an increase in an object's speed or velocity. To solve for acceleration, acceleration is equal to change in velocity over time. The unit for acceleration is meter per second squared or meter per second per second. Let us try to solve this problem. A woman is traveling by her sports car at a constant velocity of 10 meters per second. When she steps on the gas, it makes the car to accelerate forward. Further, past 10 seconds, she stops the acceleration and continues a constant velocity of 25 meters per second. Calculate the acceleration of the car. To solve this, let us write all the given data first. First is the initial velocity, which is 10 meters per second. Next is the final velocity, which is 25 meters per second. And the time, which is 10 seconds. Our main goal is to find the acceleration of women traveling. To find this, we will use the formula of acceleration. Acceleration is equal to final velocity minus initial velocity divided by time. Now, let us substitute the given data. Acceleration is equal to final velocity, which is 25 meters per second, minus initial velocity, which is 10 meters per second, divided by the time, which is 10 seconds. Thus, the average acceleration of the woman traveling with her sports car is 1.5 meters per second squared. Let us try to solve this another problem. A car accelerates from rest to 26 meters per second in 8 seconds. What is its average acceleration? To solve this, let us write all the given data. First is the initial velocity. Since it was mentioned in the problem that the car accelerated from rest, this means that the initial velocity is 0 meters per second. the final velocity which is 26 meter per second, and the time which is 8 seconds. Our main goal is to find the average acceleration. To find this, we will use the formula for acceleration. Now, let us substitute the given data. Acceleration is equal to final velocity, which is 26 meter per second, minus initial velocity, which is 0 meter per second, divided by 8, which is the time. Thus, the average acceleration is 3.25 meter per second square. And that ends our discussion on acceleration. In this video, we were able to describe motion by answering how fast is the velocity of the object is changing using the concept of acceleration. I hope you learned something in this learning journey. See you on our next science video lesson.